Here we go. Today we are looking at the double angle formulas, which we're going to derive. This is really the reason why you had to learn yesterday's formulas, which were the sum and difference formulas. So yesterday we did the sum and difference formulas, and we're going to use those to help us derive what are known as the double angle formulas. And so this is the sign of twice an angle. And we want to be able to figure out what the sign of twice an angle is, which is a weird thing to think about. So the way we do this is pretty easy. 2 theta is simply the sign of theta plus theta. 1 theta plus another theta. And then, of course, this looks like the sum and difference formulas we were using yesterday. What was the expansion for the sign of sine, cosine, cosine, sine? Keep the sign. Excellent. So this becomes sine of the first times cosine of the second plus cosine of the first times sine of the second. So sine, cosine, cosine, sine. That's what we did yesterday. And from here, well, these are interesting. Aren't they just the same thing? Yeah. Sine times cosine, cosine times, the order is just flipped, but it's just multiplying. So we can, well, 1 sine cosine plus 1 sine cosine is 2 sine theta cosine theta. This is the first double angle formula. The sine of twice an angle is simply 2 times the sine of the angle, cosine of the angle. And so that's a really easy one. This is the math that I really love. It's super fun. Okay, so that's for sine. Sine is easy. Cosine has a lot of different things that can happen here. So once again, we're trying to find a cosine of twice an angle. And again, that really is simply just 1 theta plus 1 theta. It's 2 theta, so we can. And now this is the cosine sum formula we did yesterday. What was the expansion for the cosine sum? Cosine, cosine, sine, sine. Change the sign. Yep, good, good, good. So we're going to expand this. Cosine of the first, cosine of the second, change the sign. Cosine, cosine, sine of the first times sine of the second. So that was the expansion we did yesterday. Cosine, cosine, sine, sine, change the sign. Yeah, so this is really just cosine squared theta minus sine squared theta. This is one formula for the double angle that we can use for cosine. This looks like something else. What else does it look like? The Pythagorean theorem, the Pythagorean identity was sine squared theta plus cosine squared theta equals 1. So you're close, but minus changes everything, okay? But it looks very similar to the Pythagorean identity that we learned on day 1. So we're going to use that, however. We're going to use this identity because it also involves things that are squared. And so we can use that identity, our Pythagorean identity, to sort of rewrite some things. So for instance, if I rearrange this and I get cosine squared by itself, what is cosine squared equal to? 1 minus sine squared theta. Okay, so we got to move that over. Yeah, we would subtract it. Okay. And so what I'm going to do is I'm going to replace cosine squared with what it's equivalent to, which is 1 minus sine squared. And when I do that, so I'm popping in, instead of cosine squared, 1 minus sine squared theta. And then I have my minus sine squared theta. And, well, there's a 1. And what's negative sine squared theta and a negative sine squared theta? Negative 2 sine squared theta. So this is yet another formula that we could choose for cosine of the double angle. All right, so we have a couple of choices and we have a third, in fact. Because now if I replace the cosine squared, you suppose I could do the same thing and replace the sine squared? Yeah, sure. So I'm going to go back up, and if I get sine squared by itself, what is sine squared theta equal to? 1 minus cosine squared theta. So I'm going to do a little replacing now with 1 minus cosine squared. So back to my original here. I have my original cosine squared theta minus, and then I'm replacing all of the sine squared, so I have to use parentheses. So I'm replacing sine squared, and what am I replacing sine squared with? 1 minus cosine squared. Yeah, 1 minus cosine squared. All right. And now we can do a little bit of distributing. All right, so let's see. Cosine squared theta, negative times 1, negative 1, and negative times negative cosine squared becomes positive cosine squared theta. And 1 cosine squared plus 1 cosine squared gives me 2 cosine squared theta, and a subtract 1. So cosine has a bunch of choices. Yeah, you get to pick. It doesn't matter which formula you choose. Some are easier than others, some are smarter choices than others, but ultimately they will all give you the exact same answer, okay? And again, this is one of those things where I absolutely love just deriving it, because I don't have to memorize anything except those sum and difference formulas, which you already know, because sine, cosine, cosine, sine, or cosine, cosine, sine, sine, keep a sine. Like, you know, so you know those, you know all of these, all right? And that's what I think is neat about math. So these are our double angle formulas. So let us use those, or see how we use those. So example 1, assume that theta is a positive acute angle. And again, that's important information because it tells us if it's positive and it's acute, it must be somewhere in quadrant 1. And that's important to know. And so once again, they're giving us cosine of some angle equals 40 over 41. This is a trig ratio, which means I should draw a triangle, because I might need to know it. You don't actually have to for this one, but I'm going to go ahead and draw it. So here's my theta in quadrant 1. So I'm going to go ahead and draw my little triangle, and this is the cosine ratio. Cosine is what over what? A over h. Adjacent is 40, hypotenuse is 41. Do you remember what the other side would be? 9? Okay. Is that what? Yeah, okay, good. And we got that using the Pythagorean theorem, right? Just in case you're curious, 40 squared plus something squared equals 41 squared, and if you do the math, you get 9. All right. You may or may not have to draw the triangle, but I do want to remind you that anytime you have a trig function like this, there is a triangle, which is why I did not circle it, I triangled it. Do you see that? Yeah, it's a triangle shape to help you to remember to draw the triangle, okay? All right, so we have 3 choices to find the cosine of twice theta. The cosine of twice theta. I have my triangle. Let's see, which formula do you want to use for the cosine of twice my angle theta?
I like the middle one.
You like the middle one? Sure, we can use the middle one. Does it matter which one I choose?
No.
Not at all. But we can use this one, sure. 1 minus 2 sine squared theta. So I'm going to write that down. 1 minus 2 sine squared theta. It does not matter which formula you choose. So 1 minus 2, the sine of theta. Sine of theta requires me to look at the triangle I just drew. Sine would be opposite over hypotenuse, so that would be 9 over 41. And it's being squared, so that becomes 1 minus 2 times 9 over 41 quantity squared. And from there, it's your calculator. That's it. So I have 1 minus, whoops, that's not a minus, minus 2 times 9 over 41, and that gets squared. I'm just squaring the 9 over 41, the sign ratio. Crazy decimal, what are we going to do? Math frack it, and we get 1519 over 1681. A very crazy fraction, but it is exact. That's it. That's it. All right. So was this the best choice to use 1 minus 2 sine squared theta? Probably, yeah? Well, it seemed pretty easy, didn't it? So, but we also have 2 cosine squared theta minus 1. Cosine squared theta, cosine theta, they gave to us. So I wouldn't have had to draw a triangle, because I already had what cosine of theta is. Does that make sense to you? Okay. But ultimately, does it matter? No, it does not. So let's try this one. Again, 4b, because once again, they're giving me a trig ratio here, which means I'm going to make a triangle. Here's my angle theta, and sine is opposite 28 over hypotenuse 53, and I need to figure out my x length here, so x squared plus 28 squared equals 53 squared. Will you take a moment and tell me what that side is? 45, thank you. All right, that is what I have in microprint on my paper. Okay, 45. Okay, so now that I've completed my triangle, I want to find cosine of twice that picture. What formula you want to use? First, second, or third? Since we already know sine, we could use this one. This would be the best choice, but let's go ahead and just use the cosine squared minus sine squared for doing something different. So cosine squared theta minus sine squared theta. So looking at my picture then, what is cosine?
45.
Yeah, 45 over 53 and square it minus, and sine theta would be, we already have 28 over 53 and square that. So again, really easy, and it's, just calculator work from here. So 45 over 53 squared minus 28 over 53 squared. Crazy. Math bracket, and I get 1241 over 2809. All right. One more, last one. Then we're done. I think you can handle it. Any questions so far? Don't you love formulas?
No. Yeah.
They're pretty easy, aren't they? Okay. All right. Once again, we have a triangle here, and I know that it's in quadrant 1. So here is angle theta in quadrant 1, and opposite is 8, and hypotenuse is 17. I need to figure out the x length again, so x squared plus 8 squared equals 17 squared. What is x? 15, 8, 15, 17. Very good. 8, 15, 17 is another of those Pythagorean triples. All right, sine of twice this angle has a different formula. So let me look here. 2 sine cosine. That's one you're going to want to memorize. 2 sine theta cosine theta. Again, that seems pretty easy. So it's 2 times sine according to angle theta. Yep, 8 over 17, and cosine according to theta. 15 over 17. So once again, super easy. 8 over 17 times 15 over 17. Just calculator math and math bracket. 240 over 289. Okay. All right, questions for me?
Nope.
Best lesson ever. It wasn't even 15 minutes.